Can you see my slides? Colleagues? Colleagues, can you see my slides?
Yes, we can. It's clear.
Okay, thank you very much. Like I indicated, when you check TV or you read media or you read any newspaper, you'll see that data nowadays is interpreted in terms of graphs. So we must be able to interpret those graphs. So today we are just going to look at some features that we have to know when looking at those graphs. What do they tell us? Okay, so the first one here, as you can see on my sketch, the one that I'm indicating here. Okay, this graph here, as you can see a straight line, but changing in direction. So what does that mean? Okay, this straight line means, as we can see, from 0 to 20, if you check the time in seconds, from 0 to 20, you can see a diagonal line. And that diagonal line shows the object is moving at a constant speed from 0 to 20. But when you check from 20 to 40, you can see a straight line. So what does that straight line tell us? The horizontal straight line is telling us that the object is not moving, or the object is constant, or sometimes we may say the object is stationary. But as you move from 40 to 60, you can see that again, the slope is now changing towards the right, from left to right. Then what does that mean? It means that as much as you see the line, but now the steepness tells us that the object is moving at a faster pace or at a faster rate. Okay, now compare the two lines, the two diagonal lines, the one from 0 to 20 and the second one from 40 to 60. Can you see the difference? When you compare the two diagonal lines, the first 0 to 20, it's a little bit gentler. It's gentle. But that one from 40 to 60 is a little bit steeper. Hence, I'm saying steepness means the object is moving faster. It can be a car. It can be a person maybe running. If maybe they were showing the scenario using a graph. Fine. So now, vocabulary number 1. If an object is traveling at a constant speed, it means that it is traveling at the same speed. Where do we see that? We see that from 0 to 60. Fine. But now, the gradient, as you can see, we have different gradients, 0 to 20. We have a gradient. We still have a gradient from 20 to 40. We still have a gradient from 40 to 60. But usually from 20 to 40, we'll say the gradient there is 0 because the object is not moving. It is stationary. But when you look at 0 to 20, you would see that the gradient there won't be the same as the gradient there. Okay, so one other feature is that, like I said, if a line is horizontal, like from 20 to 40, the object is stationary. This means that the object is not moving. So now let us look at the diagram on our far right. Okay, there we have a scenario of distance and time. Let's suppose someone was driving a car. So if you drive a car from 0 there, if you look at the red one, from the red one, you can see the steepness. Then from there, you can see the horizontal line. Then down there, you can see another steepness. But what does that mean? The steepness from from 0 there, it simply means that because it is not the same steepness as the other steepness on the other side. It simply says here the object was moving steadily at a slower rate. But when you compare that one of the rate, it means now the object was moving at a faster rate, but towards the downward direction. And one other thing, when you look at the green one, can you see the green one as you compare the slopes? The green one is a little bit steeper than the other two down here, which are red. That green one simply tells us that the object that was moving there was moving at a faster rate. So that simply means that if the steepness is too sharp, it means fast. If the steepness is too shallow or too gentle, it means now the object was moving at a slower rate. But if you see a horizontal line, then you have to know that whatever was moving, it is now constant, it is now stationary. Okay, let's move to the other one. Let's look at the other one. Okay. So now let us look at the relationships. Okay, graphs are the way to turn words into pictures. So now let us look at what we see here. And we have to be sure to read the graphs from left to right, meaning that whatever you see, you have to read it from left to right. So let us start with the first diagram. As you can see, you see there a line. What does that line mean? It means now, if I read it from left to right, it is from left to right, it is moving upwards. So if something from left to right is moving upwards, it means it is rising, or it is gaining momentum, or it is increasing. Then when we look at the second sketch, you can see that the very same line, it is now facing downwards. And if you read it from left to right, you can see that from left to right, there is a downwards movement. What does that mean? It means that now that the graph is decreasing. Then the third one, you can see a straight line there. So the straight line, like I indicated, the horizontal line usually says that there is no movement, meaning that the object was staying the same, was not moving. Okay, now let's look at the bottom diagram. Now I'm going to divide the graph into sections. Then when look at the sections that I have, can you see different movements there? So the first movement, it is sloping from the left to the right. Then from there, it is horizontal. From there, it is moving towards the right again, but sloping in an upward direction. From there, it is moving downwards there. So that simply means when you see that, you have to know that where you see a steep from movement from left to right in an upward direction, then we must know that the graph is increasing. Then when we see the horizontal line, this horizontal line here, then you must know that if it was a car, then we'd say now the car is stationary, or maybe would say there is no movement. But when you move, when you look at, we move towards the right, and you can see that steepness there. You can see that the steepness is from left to right in an upward direction. So still there, we say the graph or whatever is doing is increasing. Then from here, the last part, you can see that it is from left to right. When you check, you can see a downward movement, meaning that there is a decreasing movement. Okay, now let us look at this. Here we have a scenario. Okay, we have to use the graph. This is a graph to answer certain questions. So now the question is, over which intervals is the function decreasing? As you can see, I'm having many intervals here. Look at the Cartesian plane. My graph starts the last number, even if it is not the last number, on the left-hand side, we have -8 to infinity. Then on our right-hand side, we have 8 to infinity. So what does that mean? It simply means that I've drawn the graph within that interval. So now we want to check over which intervals is the graph decreasing. So I'm just going to give you some few minutes to look at that before we can discuss further. Okay, is there anyone who can try to answer the question? Over which intervals is the function decreasing? Okay, these are the intervals. Okay, these are the intervals. So which ones could you say are correct? Is it the first one? Is there anyone listening? Anyone listening?
Yes, we are listening, ma'am. I don't think the learners can switch on their microphone, so they can't respond to you.
Okay, they can't. Oh, unfortunately. No, thank you, ma'am. Okay, so as you can see, okay, I'm just going to give the answer then. I thought maybe we were interacting. Okay, thank you for that. As you can see, the graph. Okay, now let me go to the one that has some answers. As you can see here, the red color there, the red color, if you check from left to right, from -infinity up till -6, it is where the graph is decreasing. Now also, sorry for that, also between 1 and 5, it is where the graph is decreasing. Also from 6 to positive infinity, the graph is also decreasing. So those are the intervals that we were looking for. Fine. So now let's move to another scenario. Okay, now we are going to talk about continuous and discrete. What do we mean by continuous and discrete? Continuous data is data that includes real numbers. It also includes fractions. So meaning that if I'm drawing a solid line, like in this instance, if you look at this graph there, okay, if you look at this graph here, this graph is a solid line. It represents a continuous graph. But when you look at your right-hand side, you can see some dots. So that one is a discrete graph. So discrete simply means that data can be counted. So counted data can only be whole numbers. For example, if you're talking about, if maybe some girls are playing netball, if we count the scores, we can't say 4.5, we'll say 2 points, 3 points, and so on. So if we are counting using whole numbers, then representing that, we're gonna use dots. That is a discrete graph. But when coming to continuous graph could be shown by a solid line. Continuous data is shown by a solid line. And it can include also fractions, decimal fractions, and so on. And for continuous graphs, we can use time, because I can say 14:45, meaning that 1/4 to, or half past. You can see there, you can use the quarters and the halves. Also using temperature and distance. But when coming to people, you can't say you have 2.5 people. Hence, when we plot, we represent people, we use dots. And when we represent animals, we use dots. Also, when we represent objects that can be counted, we use dots. Okay, like I indicated here, animals cannot be measured in fractions, amounts. They have to be counted like whole numbers. Points must be used. Okay, thank you very much for that. So let's move to another slide. So now let's look at this slide. So what do we notice there? This is an example of a linear graph. A graph that is linear means straight line. So it is a graph that is straight. Okay, this one represents the speed of a motorbike increasing at a constant rate. So how do we see that? As you can see, checking from our left to our right, then we can see that upward movement. So that upward movement shows that there was an increasing, it shows that there was something was increasing. Okay, now let's go to the second one, decreasing graph. How do we check this decreasing graph? The graph that slopes downwards from left to right indicates that the dependent variable decreases as the independent variable increases. In simpler terms, we may say, for us to be able to check whether the graph is decreasing or whether the graph is decreasing, we have to check from our left. Always we start checking from left to right. So if it is sloping downwards, then we know that that graph at that interval is decreasing. Okay, now let us look at this one. When we look at this one, we can see that there is no movement. It does not have an upward movement or a downward movement. It is the movement, the movement is only horizontal. So that simply means that the movement here is staying the same. There is no change, meaning that this example of a graph is example of a constant graph. Okay, now let us look at this one. All right, we talked of linear graphs, but sometimes we may come across non-linear graphs. Like in this case, a non-linear graph is a graph that is not drawn like a straight line, meaning that it is the opposite of a straight line. We have straight line graphs, we have non-linear graphs. So when we look at this one, that was showing the growth of an infant age between 0 and 18. You can see that it is not a straight line. So this one graph represents a non-linear graph. Okay, so now we have a question here. Okay, now let's imagine walking to a shop. Let's imagine maybe Elena is walking to a shop near his home to buy something. And then the learner must come back home. So this graph shows that scenario, the relationship of from home to shop, at the shop, and moving backwards. So the graph here shows the relationship between time passing and the distance you'll have from your house. Okay, so if you can notice at my sketch, there are 4 points labeled along on the graphs. I'm having point A downwards here on the horizontal x-axis. On top there, I'm having letter B, I'm having letter C, I'm having letter D. So what is the meaning of this? We are representing that scenario using the graph. So from A here, it means that learner is walking towards the shop. And as you can see the graph, from left to right, the graph shows what? An increase, meaning that the gradient there is increasing. But when you look at B and C, while the learner is in the shop, it represents a horizontal line. So what does that horizontal line mean? It means now the learner is now in the shop, maybe buying something. But when you look at C to D, now the learner is walking back home. Okay, but now if the learner walks back home, what does that mean? Now when we check the gradient, the slope from left to right, we can see that it is now moving towards a downward direction. So it means now at that point, C and D, we have a decreasing graph. From B and C, we have a stationary graph. Then from A to B, we have an increasing graph. Okay, so now I would maybe ask a question that which part of the graph shows that the distance from home is constant. So as you can go back to what we had, as we can go back to this diagram here, what do you notice? Okay, even if learners cannot answer me, but I'm just going to pause for them to check what they have to know. All right, so, okay.
Ma'am, this is Mr. Potgieter here. Can
Yes.
I ask you to finish off since natural science had to start their lesson
Okay.
already? So
Okay.
maybe,
Yes.
please.
Yes. No, thank you. I'm going to wrap up. Okay. Now, I'm just going to summarize what we learned today. Let us look at this. Okay. The first diagram there, it shows a continuous graph because it is represented by a solid line. Then the second one down here, number 5, represent a discrete graph because it is represented by dots. Okay, but when you look at that top one, number 4, you can see that there is a different change in direction. The steepness from left to right, as you have to remember that when we check whether the graph decreases, increases, we always check from left to right. So if it goes up, it increases. When it goes down, it decreases. When it is horizontal, it is constant. Thank you very much.